Okay, guys, this is Unit 5.5, Slope Applications. And basically, it's word problems, so it becomes a lot more challenging, as you know. Now, I want you to be comfortable about it. The way to deal with word problems is to read carefully and read it slowly, and then label it with whatever mathematics you know and translate it into a math language. And then from there on, the math part actually is really easy because you already know it, right? So let's look at the example here. The table below, excuse me, shows the high temperatures in degrees of a city during the first part of June. So June 1st, June 6th, June 8th, and June 14th, and the temperatures that you've got down there. Now, A, find the rate of change. Rate of change, we know it's slope, so label that in high temperature between June 1st and June 6th. Notice that I highlighted or circled important words and I translated, right? So in order to find these 2 points, I need to first understand June 1st is here and June 6th is here. So I've got 2 data points. I also know that my slope formula is what? y2 minus y1 over x2 minus x1. If it's helpful, see this part of your note packet, there's space. Just, you know you're going to use this frequently, so just write it down there and help yourself. Remind yourself about it. So June 1st, I'm going to have 2 data points. First is 72 degrees, and June 6th is 76 degrees. So if I have a table with an x and a y, and I got my x1, y1, x2, y2 right here. So now I just need to plug it in. And so it's 76 minus 72 over 6 minus 1. I should have 4 over 5. That's it. Leave it there. Okay? So that's the rate of change. So, but because it's a word problem, the rate of change, meaning each day it goes up by 4 over 5. If you have a decimal, sometimes people say 0.8 degrees per day. And that's fine too. So give me the unit there. Okay? I'm going to leave 2 to yourself to do. And then let's look at C. I'm going to move it up a little. During which of these intervals, time intervals, did the temperature rise faster? Ah, that's interesting. So what do you think? I think it's between, you just have to, in this case, one thing to do is you can calculate the slope. You calculate the rate of change between each period. That works. Or it's simply a subtraction, right? 76 to 70, when it rose from 72 to 76, that's 6 degrees. And then it went up from 84 to 76, that's 8 degrees. And then 86 to 84, it's 4 degrees again. So obviously, the part that rose the fastest is this period, and that's 84 to 76. In other words, the temperature rose faster between, I wrote a shorthand there, June 6th and June 8th. That's it. Okay, so make sure you finish the second problem. I will give you the answer there. It's 4 degrees per day. Should be the answer. Second problem. Josh started a diet and decided to record his weight every other week. So week 0, week 2, week 4, so on and so forth. Find the rate of change between 0 and 2. So rate of change right here, 0 and 2. So again, m equals y2 minus y1 over x2 minus x1. I'm going to write it on the side. I have 0, 2, 2, 4 as 1 point and 2, 2, 1, 9 as one set. So this is y, this is x. Notice I do a shortcut. I usually just line them up, stack them up vertically like that, and I take the first y minus the second y. I take the first x minus the second x, and that will give me the same answer. That's negative 5 on top, negative 2 at the bottom. I should have 5 over 2, and that's fine. Or you can say it's, especially it's application problems, if your calculator tells you, oh, I'm sorry, I made a mistake here. Sorry about it. I'm not going to erase it, but I'll overwrite it, okay? Notice this one is positive, so which means this is negative here. So it's negative. So that would be pounds. That's pounds per week. 2.5, he lost 2.5 pounds a week. That's pretty healthy, actually, a good rate to lose weight. So same thing between B is to find the rate of change between week 2 and week 4, and then C is to find between week 4 and 6. So I will write the answer here. I expect you to finish these problems on your own. And notice that 1 and 2 is negative. I'll highlight this with red. We calculated as negative, right? For the second problem, or B rather, m equals 1 pound per week. That means he didn't lose it. Instead, he gained 1 week back, 1 pound back, and that's fairly normal. But as long as he's diligent about it, he's going to lose weight. And the last one is to find the rate of change from 6 and 8. And obviously, you actually don't need to think too much. If you just look at the number, his weight didn't change. So the rate of change, if you calculate it, is 215 minus 215 over 8 minus 6, which is 0 over 2, which gives you 0 pound per week, meaning he didn't change. But obviously, just from the observation, you will get that. What does this mean? It means that the rate of change is 0, and he didn't lose any weight. No weight loss in this week. Okay? Okay, let's look at this page. Next page, number 3. The graph below shows the number of miles driven after each hour of the road trip. So in other words, let's dissect this a little bit. Notice that the x-axis, 2, 4, 6, 8, those are hours. And the y-axis, and those are miles. And this line, this crooked line, would indicate the relationship between the hours and the miles, right? How many hours later you travel, how many miles, that's how we read this. So let's look at it. Find the rate of change between hour 1 and hour 4. Now, I'll change it. Hour 1 is here. Hour 4 is here. And the mileage is indicated by these 2 red dots right here, right? So I have to read the coordinates. I'm going to call this point A and point B. So point A would be 1 on the x-axis, 60 on the y-axis. Point B would be 4 and 160. So now that we've got 2 coordinates, it's easy, especially I line it up, I stack them up, right? So I just use the 6, this is y, this is x. So It's y2 minus y1. As long as you keep it the same order, top to bottom, you're fine. So I have negative 100 over negative 3. So it's approximately 33.3, right, miles per hour. That's how we do this type of problem when a graph is given. Excuse me. So pause the video and finish B. I will give you the answer here, but you should do it yourself. You cannot drop the unit because you're telling me how many hours that, how many miles per hour that you have moved forward. Without the units, it doesn't mean anything. It's just a number, right? So let's look at number 4. I'll move it up. Find the rate of change from 2000 to 2004. 2000 is right here. 2004 is right here. So we're talking about these two data points here. Find the coordinate. In 2000, I have 58. So you have to calculate. If this is 58, this is 66. 66 minus 58 is 8. There are 2 blocks here, right? So I divide it by 2. That means each of this block represent 4. So this right here is 62. So I have 62 feet. And then in 2004, I have it up here. So then I add another 4, that's 78. That's how we read it. And then you calculate the slope, which is 62 minus 78 over 2000 minus 2004. So you should have negative 4 over negative 4. I have 1. Is that right? Oh, sorry, I made a mistake there. This is not 4. This is negative 16. So you should have 4 as the final answer. Okay? So I do make mistakes often, and that's 4 feet per year. Check your unit. So try to do the second one on your own. It should be the same thing. I'll write the answer here. I think this one is negative 4. Number 5, this type of problems are really interesting. I'm going to move it up. It says Ava started a savings account with $500. After 6 months, her savings account balance was $731. Find the rate of change. So again, line up the data. Month 0, before you reach the first month, you've got $500. In 6 months, it went up to $731. That's a good deal. So the rate of change is 500 minus 731 over 0 minus 6. So you would have negative 6 at the bottom, negative 231 on top. So it's approximately $38.50 per month. Okay? And number 6 is pretty much the same thing. So start with the time. 0 minute is 36,000 feet. And then 12 minutes later, it's at 29,400. And then you calculate from there. So you should have 5. So give me the calculation. Don't just give me the answers, okay? 7 and 8 are the same, so do that. Pause the video and I'll write the answers here. That's it. All right. So to summarize, the first step to find rate of change is to find 2 points. They are either in the table, or they're in the graph, or they're in the words, in the descriptions. Find x, y, 2 points. And then use slope formula. And finally, attach unit description. Sorry about that. Misspelled word description. That's it. Okay? The hard part is not on the calculation. The hard part is on the thinking part, is figuring out what's connected with what. Focus on the basics and identify what you need and then go from there. That's it, guys. I will see you in class. Bye.